Thanks to the organizers of Wanxiang Global Blockchain Summit to invite me to give a talk on the topics. The hardest right now, I think everybody agree, will be the merge that Ethereum will merge from the proof of work to proof of stake. The proof of stake is definitely not a very, very new thing. Obviously, as a practically workable mechanism, we're still waiting to see. But the study on this topics has been going on for quite a while time, and as a result, I also have been done some work and also give some thoughts on this very interesting and very important topic. So I will mention two. I will just give two kinds of big thoughts on the issue, and the first one is about the idea of slashing and the smart contract. So let me start with the one. The second one will be the concentration that everybody we're talking about right now. So first one, it's really the idea of the proof of stake. Why it seems like it's so nice is because that instead of doing the mining, which is the energy, a very costly and exhaustive mining activities, the idea is to replace the mining, of which is the incentive, replaced by slashing. So the slashing is basically saying that we can provide the incentives by you putting some money there or stake there, and if you do wrong stuff, we will slash you. And remember that it's very important to differentiate the in economics on equilibrium versus off equilibrium. The key idea is that if on equilibrium, because of the off equilibrium penalty, that will prevent you from doing bad things on equilibrium, and as a result, pretty much like a zero cost of providing incentives, right? Okay, so as I said here is the validators, they put the deposits there, and that's in some sense it's just time money there. It's not a real cost. It's just some time money. And get slashed for protocol misbehavior or rewarded for being a good citizen. And that just emphasizing the carrot side. And from the mining, if you think of a proof of work, that's kind of a combination of carrots and the sticks. But in order to to be able to putting on blocks, you need to do a lot of crazy mining, which is extremely costly. So as a result, that this is a much better, in my mind is clearly in whatever the dimension, it dominates the proof of work. It is also a great application to smart contracts that also get the economists excited. And the bottom of the slides is showing you the number of slashed Ether2 validators. And remember, this is basically there's a beacon chain is running before the fully merge, and this is basically all the stuff inside of that chain is kind of empty. Is people play with it? It's like a game, and but you still can put your signature, all these things. And these are the slashed Ether2 validators, just showing that the incentive provision seems to work. Okay. What is interesting to me as an economist is that seeing this, I do not immediately see that this is working. Okay, so here's the thing that wait a second is that first of all, who manages the smart contracts, and the second is who executes the reward and the penalty. And you can't say, oh, some machine is doing it. That's really not true. In the end, there's someone behind it, right? So why this is the case? Because there cannot be a centralized machine which acts on agents' behaviors, right? That's the whole point of having a decentralized system, as a blockchain has been advocating. So basically, that in some I took it a paragraph from a consensus rewards and penalties on Ether 2.0. That's a phase 0. That's a trial phase. And it just said in all these cases, the offender needs to be caught in order for the slashing process to be triggered. The whistleblowing validator will create and propagate a specific message containing the offense for Prosper to include it in a block. You see that it's quite, when you think through it, it says, first of all, someone needs to do bad thing. And as a result, you need a whistleblower to find it and then start to say, look, here is the offense. And then some prosper, let's say, sounds like a policeman in the practice to include in a block, and then people just vote on it, and then, okay, you did something bad, therefore you need to be slashed. Okay, so all these things just, it's fascinating, as well as, involve lots of practical mechanisms of providing incentives. Now, at this point, then people will say, okay, you don't need to worry about it because we have smart contracts, right? And as our doing some work, is that a smart contracts of blockchain act on some consensus, decentralized consensus. Now, I would like to really emphasize this point that, as we emphasized in our earlier paper with Will Kahn, is that they only act on decentralized consensus. That's in some sense, it's a very deep word. Is you have to be decentralized, and also has to be consensus. But if nobody is working on to make some offense to be a decentralized consensus, there's nothing will be caught. Okay, so this is basically the starting point of my thinking. So what is a smart contract? Okay, from a computer scientist's perspective, very easy. It's just a piece of software code that implements certain pre-specified logics. Basically, this is the best example. If you did something wrong, then I will penalize you. Okay, and then the second part is actually more important than the first one. Is the same code runs on every node on a blockchain, and if everybody runs the same code and you get the same input, then blockchain is realizing the penalization across the entire internet and immediately reach consensus. There's a lot of a technical side, technical development to ensure that, but as economists, actually seeing smart contract, it's very misleading, okay? Because if you know the work by Oliver Hart and Holmstrom, that's the two of the great economists around won the Nobel Prize for the contracting issues in economics. The first question we will ask is the input variable, which is the bad behavior, contractable? So in some sense that we can making sure that this is a bad behavior, therefore we need to penalize you, right? It is become extremely tricky because it's not like if you did a bad behavior, then immediately that bad behavior is contractable in the sense that it become as I said, decentralized consensus. So here's the point. Is that, contractability is a very important issue in the POS system, because the contract variable, that input, has to be equilibrium the objects, and in the in the blockchain world, it's can only act on the on-chain variables, which means that if someone did bad things, a whistleblower will call it out and then propagate it to all the community, and then all the community seeing it, verify it, therefore put it on the chain. And at that point, then the smart contract can start to implement. So as a result, there's a lot of pre-steps before you putting the bad behavior on chain. And this is where the smart contract in the computer science perspective start to operating. But for economists, we perhaps more interested in knowing in the previous steps, how do you bring any offense to the on-chain? Okay, that's about incentive. And obviously, there are a lot of people working on that thing, but we are more interested on that part. What's important is that it brings to the different perspective of economists and the blockchain is that, a lot of times we will assume, economists will assume that all the a variable, if they're observable, which means that everyone see it, right? As a result, the court will see it. It's called observable. And we typically will say, okay, if it's observable, then there's a way to make it contractable, because the court can ask a team to inspect and blah, 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 and then you get the contractable. This is not that easy in the blockchain world, because for blockchain, a lot of observables, let's say price, is off-chain data. And there's a great improvement, a great work on this community to bring the real world data, but off-chain to on-chain. And that, I see a lot of breakthrough on this field, but that's still ongoing, right? And I do think that how do we bring the off-chain data, including some behavior is bad behavior, to on-chain so that a smart contract can slashing out? That's the very big component of next, at least 5 years of a blockchain technology progress. Okay. Now this brings to the key idea of how do we implement things, right? So usually the proof of stake is using a variant of a Byzantine fault tolerance, this is basically there's a practical BFT, but there's a practical Byzantine fault tolerance, right? Kingdom main hot stuff, different variants, but essence is the same, which is a leader. There's a different blocks, so one block has this feature, and then you just move on. Okay, in that block, a leader first propose a block, then group of backups then vote. They see the leaders propose the thing, they check stuff, and then they vote. Okay, consensus may be reached after multiple rounds of voting, and obviously depends on the nodes, whether nodes are faulty or not, or malicious or not. So they typically are assuming some exogenous fraction of honest and malicious nodes, and computer science are able to prove that if the fraction of malicious nodes is below 1/3, then after multiple rounds of voting, you will reach consensus. Typically, they're assuming so-called honest nodes, which is a very important components for the computer science logics. But as economists, we typically start to frowning because we think, what do you mean by honest? Everything is subject to incentive. So what we are, I done some work is basically try to generalize the honest to something that we are familiar with economists, which is rational. Okay, because we think that in the future, then when the blockchain is used among different organizations, then different organizations will have very important things to consider, which is the incentive, which is why do they want to participate. In the old time, because all these distributed ledgers, just within organization distributed ledgers, the incentives issue is much less concerning than now. Okay, so we study the situation of BFT where the nodes, every node could be rational, could be malicious or Byzantine, and study the incentives for this game. Now, linking back to what I was, in the previous slides about the smart contracts, how do you, penalize the bad nodes, is that, the whole idea is to, the leader will propose a block that potentially include these bad behavior, then voters will vote, right? The key idea is that hopefully this way of arrange the blocks will successfully reward or penalize bad voting behaviors. That is not necessarily true. If everybody is honest, yeah, then there's no issue. But then if everybody is honest, you don't need a blockchain anymore, right? So relatively easy to reward or penalize bad voting behavior. I read you can check the codes, and because of money transactions application, which is the most of the blockchain right now in the United States, even that is about, this is very, very easy to check, right? You have a certain way of checking whether somebody's signature is correct or not, and does the money amount match the original proposal? All these things are just to make it very easy to check. However, I do see a big of a gap from even if that in the current POS of Ether 2.0 successfully emerge and everything is running good, I will still kind of concerned or just want to see and being convinced that that way of reward and penalize can be easily carried through other real applications where the black and the white is not that clear. And how do we know that some voting are really indeed that honestly voted to be matching to some practice, matching to some practical truths. So that's the connection of the BFT and the penalty and the reward. So motivated by this this logic that we did some empirical investigation. It's kind of easy. It's just we see the proposal attestation records on Ether 2.0 beacon chain. That's basically this part. These are just all the data is coming from the beacon chain 2.0. There are 2.5 million blocks, and we can just check. And the focus of our study is really try to see that do we see protocol violations eventually gets slashed? Okay, so it's like on the chain, you see somebody, you can see whether somebody did bad things. As an inspector, I cannot slash them, but as an inspector, I can see that whether some blocks actually had some bad behavior and try to verify whether these bad behavior gets penalized. So these are the bad slashable events, double proposal, double attestations, surround the votes. The finding at this point is that it seems most of them being caught, or I would say that every on-chain offense has been caught. But is that good enough? Has two important facts. One is that indeed that on equilibrium, actually, even given this incentive, some bad behavior still occur. Okay, that means that maybe we can better design the incentive scheme. So in some sense, penalty is too small, so that the people still do bad things, right? The second more important point is, are there any bad behavior, right? It is occurring, but nobody is bothering to bring them on chain. As I said, nobody bothered to bring them on chain. Now that is also very important, because what's really important for economists is saying that do you have an incentive to misbehave? And sometimes I misbehave, and nobody bothered to check on me. So as a result, that it's there, but it's not on chain, so I'm not penalized. If there are a lot of them, then obviously I will keep doing bad things, right? So we do find some off-chain misbehaviors. Now we are in the process of checking their validity, etc. So these are along the lines. I think that it's a very interesting topics that in the future, when the merger happens, that it's on some will bring a lot of or attract a lot of research on it. So I have explained to you my thoughts on the slashing incentives, as well as the deeper economic mechanism of smart contracts. And I do think that will attract a lot of research in the future. Now I move on to another important issue, which is the stake concentration in proof of stake. Okay, and recently gets a lot of attention because people realizing that merge is coming. So how do we do, and how did we do in this trial beacon chain there? And here is one figure really tells everything. Is that look at take one time, I believe it's the last month, and then take a snapshot of all the deposit share of these various entities. So you can imagine that each one representing a node or a group of a node. So the one that really stands out is the 31%. I believe it's Lido, but maybe it's different just because I believe it's Lido. All these colors are almost not distinguishable. But the whole point is very clear, is that look, there's one guy really powerful, 31%. And it's concerning because the whole point of the decentralization is to let a lot of people, small people can can voice their concern, so that the world is more equal. Now that is important, but then that leads me to think: is this like from the beginning always like that, always very concentrated, or just a recent event that because that the people start to really get in this community? Here is a stock concentration over time that you will see. Interestingly, that I do not see a increasing trend for the concentration. If anything, that it's actually a lot of people getting in, and I would say that perhaps the concentration goes down over time. Now, I do not know. Just from here, I think that the reasonable statement is that there's no clear trend of concentration from the decentralization goes to centralization. And that's interesting because we remember in the old time of the POW, when the Satoshi's blockchain, Bitcoin goes up, just start to caught people's eye. In the beginning, a lot of small people using their computer, game computer graphic card, they can do some mining. And at that time, it is very, very decentralized. And then slowly people realize that, oh, we can do better by forming pools. And then, larger pools start to dominate and all these things. So you see a clear trend from decentralization to centralization. And it's easy to explain just because initially people just don't take it seriously. And then later on, people take seriously. Once you take seriously, a small difference in the advantage, either in terms of mining or communication or equipment, all these things, very, very easily translate to a big difference in staking or their market power or market share in equilibrium. Okay, we do not see it in POS, so that's an interesting fact. The second, the real thing that I would like to point out is that as I also explained in the beginning, that in the first plot showing that it seems like there's no equality, but you have to understand, you have to ask yourself: is that necessarily the case that a decentralization implies equality? In my mind, decentralization is kind of a mechanism, just means that everybody has a chance, or there's no rule ruling some people out. Okay, equality is outcome. It's not a mechanism, it's just the outcome. It's, ex post, we check whether there is equality or not. You should not put a easy equivalence between these two, for obvious reasons. And, in practice, there are a lot of cases that there's everybody has equal opportunity, but not necessarily equal outcome. Okay. So as a result, I do think it's very important to think about decentralization as a competition. So what I do want to emphasize is that a concentration without a competition threat, okay, which is guaranteed by decentralization because everybody can come in to threat you, to challenge you, challenging the incumbent, is very different from a concentration with a competition threat. Okay, so the latter, which is I think is decentralization guaranteed, should work better. Now, the question is that whether that these natural monopoly power will build a wall to prevent other small people to come in to compete. It's an interesting question, not just for blockchain, but also for other field. And we're waiting to see in the next 1 or 2 years to see that whether the POS can circumvent this natural problem that are facing almost every economic activities in the world. Thank you.